Welcome to our journey to understand the fundamental logic in computers. We begin outside the computer, seeing it as a complex system made up of various interconnected components. As we move deeper inside, we'll enter a microscopic world where the logic of computers begins. Now, we dive deeper into the computer. Watch as data flows through cables and electronic components. Here, at the heart of the computer, we'll encounter transistors, tiny elements that play a big role. Here it is. The transistor, a crucial component in the computer. A transistor works like a switch. It allows or blocks the flow of electric current. This tiny device enables the computer to perform basic logical operations that form the basis of all computations. Essentially, a transistor transforms electrical signals into binary data, which only has two states: on, 1, and off, 0. The working principle of a transistor is quite simple. When an electrical current flows through it, the transistor activates another path, allowing or blocking the flow of electricity. By controlling this current flow, a transistor represents binary data, which is used to perform basic logical operations within the computer. Without transistors, no calculations or data processing would be possible. The NOT logic gate, also known as an inverter, flips the input signal. If the input is 1, the output becomes 0, and if the input is 0, the output becomes 1. Input 0, output 1, input 1, output 0. The NOT gate is the simplest logic gate, and it plays a key role in building more complex logical circuits. The AND logic gate produces an output of 1 only when all its inputs are 1. Let's look at the truth table to understand how it works. Display the truth table: input A, B, output A and B beneath the logic gate as shown in the image. Row 1. Input A equals 0, B equals 0, output equals 0. Row 2. Input A equals 143, 0, B, aber 1, output aber 0. Row 3. Input A, aber 1, B, aber 0 to output equals 0. Row 4. Input A equals 1, B equals 1 to output equals 1. The AND gate is one of the fundamental logic gates in computers, enabling data processing in this way. The OR logic gate produces an output of 1 if one or both of its inputs are 1. Let's look at the truth table to understand how it works. Row 1. Input A equals 0, B equals 0. Output equals row 2. Input A equals 0, B equals 1. Output equals 1. Row 3. Input A equals 1, B equals 0. Output equals 1. Row 4. Input A equals 1. 1, B equals 1, arrow, output equals 1. The OR gate is one of the basic logic gates, enabling flexible data processing where the output is 1 as long as at least one input is 1. These three logic gates work together inside the computer to perform more complex operations. By combining them, the computer can perform intricate calculations, from running programs to making decisions in everyday applications. Here's a snippet of the process of creating this video using Blender.